Good morning, good afternoon, good evening. Thanks a lot for joining today's tech chat on the modern software-defined data center and what we at Datera are up to try and bring that software-defined revolution to the data plane and the data level. We're joined today by a group of folks who built the product so that we can talk about the details. And our whole point today is to answer your questions. So we've got a pretty good sized audience out there today, so thanks a lot for making the time. And our goal is just to get your questions answered and then also provide you resources where you can learn more. So we're joined today by a handful of folks. First, I want to say thanks to Charlie Milo, who's a Senior Solutions Architect from Intel. Thanks, Charlie, for joining today, along with the rest of the team from Datera. And in the room, we've got co-founder and Senior Software Architect, Nick Bellinger. We've got our Head of Engineering, Narasimha Valivede. We've got Head of our Container Software Design, Shailesh Mittal, and also Field Technical Lead, Bill Basari. So with that, we're going to move directly to questions, and I can see questions in right now on the line. So the first one is just to talk a little bit about, looks like, look, what are you about? So Nick, I'm going to talk this your way, throw this your way, and just why'd you start this place in the first place?
So we kind of saw a number of folks doing software-defined 5-6 years ago, and a lot of them were using the software that we contributed to the Linux kernel, which is the iSCSI target and fiber channel implementations. And so we saw some kind of interesting scale-up models to start, but we knew that scale-out combined with tiering was going to be a pretty powerful architecture for us to pursue. And that's kind of the basics that we started with, and from there it kind of continued into, policy and application intent. And we ended up really solving some of the hard problems, computer science problems, and really one of the big ones was transparent data movement. How do you non-disruptively move data across multiple generations of server and storage? And you do that using policy automation.
Okay, so that was the basis of this. We started this thing back in 2013 and came out with the first production use in about 2016. And first question that I got even before the session even opened was really just the differences between this and the old way that we used to approach storage in the market. So, VNR, that's Narasimha's typical discussion around here. That's his typical name around here. You came from the dual-headed array industry, so tell us a little bit about the differences now that you've been here for, what now, a year?
I've been here for 9 months. The dual-headed or a dual controller arrays, one of the things is, the storage is in place, and Nick talked about, transparent migration. So if you are actually trying to use the data, and data is important for folks, and the access to that data is very critical. And as your workloads start using the applications start using it, you want to kind of have a way to provide a better response, better latencies, and available as a workflow. The old way, dual-headed or dual controller, it's a silo, right? Whereas when we have a scale-out architecture with shared nothing, gives you advantage to kind of move the data to the application or the workload or the use case that you would want to. For example, if the application wants a better latency, better throughput, better IOPS, then you move the data closest to that application and to the media that gives you that characteristics. So as I look at it, it's a system built for data migration and helps the applications.
Got it. So Bill, you spent time in this industry for a long time on the dual controller side like I did. Tell me about you.
Yeah, so, I mean, if you think about it, the concept of two tightly coupled computer systems managing storage is about a 30-year-old architecture, maybe an older. And what we're seeing is it's time for change. What's driving that, and what we talk to customers a lot about, is the explosion of data that they have to manage. And it's not only their existing and traditional infrastructures that are growing and being and requiring not only more capacity, more IOPS, more agility, but we're also seeing new types of applications coming into the data center around analytics and other ways that people are gaining more information about their environments and ultimately making more money. So what ends up happening is, how do you build a system that can manage potentially tens of petabytes, but also deliver an ultra-high performance response to critical transactional databases? That is a very tough engineering problem, and we've not seen anything else in the marketplace that can really solve that. But the architecture, and as Nick and VNR mentioned, that data migration really allows this to happen, because it's not just about solving for the future, it's also using that to make a very agile system. So it's a combination of the dual-headed architecture is very successful traditionally, which is why a lot of companies have chosen to keep it. And solving those problems is actually very difficult from a computer science perspective. And the driver at the end of the day is this change in applications, the change in data sets, the need to store so much more, there's compliance. All of things are making it very challenging for the IT shops.
Okay, cool. So another one came in on the topic of really just in general, what people are trying to do with the software-defined data center these days, right? And we got a lot of people that are trying to move to that. So Bill, talk a little bit about beyond storage, what's going on out there, and then I'm going to ask Charlie the same, because he's with customers every day.
Yeah, the concept of software-defined data center has been around for a while. The goal, in my opinion, is around agility. If we think about what services hardware used to do, load balancing, networking, all those features, those capabilities are required to build a data center at any kind of scale, we're seeing them transition into software products, because the base fundamental building block is compute, and the Intel platforms have driven so much compute that you no longer need specialized hardware to deliver the same kinds of throughputs and responses that we used to see ASICs being generated for. So when you start moving into that software model, it gives the enterprises and service providers dramatic control over how resources are used, how you expand the infrastructure, how you support new applications, all of those sorts of critical tasks that businesses need to do, software defined from a network perspective. And you can think of VMware as software-defined compute and cloud and all that, and then the storage aspect. It all comes together.
And Charlie, you're talking with folks out there all the time about what they're trying to do in their data centers, and you're talking with some of the biggest customers in the world. So give us your perspective.
Yeah, absolutely, Chris. So first of all, I agree with everything that Bill said, and also, Intel is very excited to be working with DoTERRA. As the audience probably already knows this, but DoTERRA solutions already built on commodity x86 servers. So using, for example, the latest Xeon processors allow for the scale and performance that you're seeing with the product from DoTERRA, and then including things like our NAND SSDs and SATA drives and the NVMe drives, this is going to get great performance. And I think what you're seeing from large customers is they want to get to the level of automation. I think one of the challenges that large customers are also seeing, as it was said earlier, the explosion of data. Very hard to predict the amount of data, the projection of data as it grows. And so they need to automate this, and as it was stated earlier, they have to be agile to meet that demand, to meet the SLAs of lines of business. So this type of solution is probably one of the best solutions to meet the demands of these large customers.
So, yeah, that's helpful. I mean, I think that's clearly where we're going. So, one question came in on the topic really of around performance, right? And it's basically saying you claim sub 200 microseconds latencies, but how should we be thinking about performance? And can you DoTERRA prove you actually have it? So let's give that one to VNR, and then we'll go to Nick.
Yeah, I think the performance, as you said about the less than 200 microsecond latencies, the way that the architecture is, right, we actually have a way to have the infrastructure that allows us to absorb all the writes in our NV layer, non-volatile layer, and then we actually acknowledge the writes. Once we have a quorum, we acknowledge the writes. And as a follow-on, we kind of destage the writes from a NV layer to the actual media, right? So that actually helps from a latency perspective to get the right latencies. Do you want to actually talk about the other?
Absolutely. So that's what VNR is describing is our lockless coherency protocol on our backend fabric. And so essentially it's a two-phase write protocol that allows us to acknowledge from persistent byte addressable memory, i.e. NVDIMM, NVRAM, and soon Apache Pass. And so the latency that the host sees is really only the standards-based transport into our system and then the number of replications on the network to meet the replicas and back on the back end. But the point that VNR made is really important that we're able to send down log structured writes to the underlying flash media from that persistent memory. And so in a number of systems who don't support persistent memory, they're doing constant read modify writes to the underlying flash media because the host is sending small block writes. So we're able to send down 1 megabyte size writes to the flash even though we may be receiving a 4K write from the host. And so that allows us to have really exceedingly good long-running performance and endurance to the media because we're not constantly doing read, modify, write down. Mm-hmm. And another really important benefit of the architecture that we've implemented is that the data services, i.e. compression, encryption, deduplication, are done in the second phase of the two-phase write. So the host doesn't actually see that latency. And so since we acknowledge early and we destage, it gives us a lot of efficiency as well as work well with the underlying media over years and years.
So the idea is you get these services, but it's not compromising the performance.
That's right.
It doesn't impact.
And Charlie, we did some testing with you, so maybe you want to talk about your experience on what we were able to achieve on the performance front.
Yeah, well, first I'd just like to even jump in and mention what I like about DoTERRA. For example, you talk about building the clusters of built on commodity hardware and using any type of products that are on the market, the Xeon processors or SSD storage. But we took this product in our lab and we built it up, and with Bill's help, we were able to do benchmarking testing, and we were able to show different performance levels, whether it be starting out with SATA drives and then moving to NVMe, but then also moving to some of our latest greatest product technologies, the Intel Optane based on the 3D Crosspoint. And what we were able to see is the write performance get drastically reduced. And the point I would emphasize is, when Intel introduces new technologies, it's a challenge to get it out there in the market, to get the right line of business to benefit, see the benefits of this technology. And with DoTERRA, because their system is modular in the sense of a cluster, and then we can put certain new technologies in a particular server, storage node, they can test this, and the application can be pointed directly to that node, and you could actually run benchmarks. And we've seen through the benchmarks that we did in our lab how this could have impacted a line of business. They could have saw the immediate value in which the new media type from Intel provided, and then immediately went to that technology. So again, the results were excellent. We got some really great low latency numbers as we moved up in the advanced technologies of Intel storage media, and I think this is going to be an easy way to prove this out to customers.
Okay, that's helpful. So, performance is a key theme. If you don't have performance, you die. And we've seen a lot of companies that have tried software-defined in the past, and they failed. You can go to our blog if you want to read about some of them. We have some nice tombstones out there commemorating them. One question came in over the chat line that draws my eyes because I came from the unstructured data business for a long time. The question is, most data out there is unstructured. Is DoTERRA going to support this? Does it support it now, and when?
Yeah, so Chris, let me take that.
Yeah, VNR, please.
So we talked about how we have the architecture that provides the infrastructure, the latencies. But we also want to kind of make sure that the platform provides the data services for the customers, right, end customers. So in that sense, we started expanding our data services. We created a framework. So while we started with block, now we started adding object. Now the object would actually help in supporting the unstructured data, right? Where so we just released that in the last quarter. That's something that can be used for performant object as customers wants to use it. Obviously, different block sizes, object sizes will support it as we go forward. The intent with the data services platform is the infrastructure that we have that Nick talked about that can be expanded with other data services as well, right? Block, object, file, and other things. So that's on our plan. So what I'm trying to say is the architecture is such a way that creates a framework that we can actually expand on how it can be consumed or how the user wants to consume at the end, right? So block object is the thing. Yeah.
Yeah, and to build on what VNR is saying is that there's two fundamentals. There's the what is the data set, how does it get in the box, and then what is the box doing? Because our architecture is scale out, shared nothing, and we've really designed it to be so future-proof as well as very agile, if you looked at our node qualifications, you can have a 100 terabyte or more disk-based node. You can have a 5-10 terabyte Optane node existing within the same system. So as customers are dealing with not only the quantities of data, but the change in the application side and how those applications are accessing the data, the system can be composed to respond at the appropriate metric. Are you looking at a latency IOP optimized workload? Is it a $1 per gig workload? And our system is very unique in that in one management entity, you can have all of this different capability, and then you can segregate what happens based on those policies.
So I think that leads us right into the next one, which is on media and media placement. So talk to, a lot of systems start with media placement and say, this node, this location, that's it. Talk about our media placement. So Nick, maybe we start with you on that.
Absolutely. So, I touched on a little bit earlier was the transparent data movement is a core function of our system. And the way that we achieve that is all placement from a distributed storage perspective is done using floating metadata state. And that allows us to make arbitrary changes to the system. And that really means within a single application, within a single volume, within a single application, we can mix and match any storage types that we want. And so you can think of the DoTERRA data path as logically decoupling the I/O fast path from the data movement in the repair path. And so we essentially have an I/O fast path that can be reprogrammed non-disruptively to make updates to that data placement. And so what we see in practice, how people actually utilize this, is say they'll start with a certain placement policy. Let's say all replicas on hybrid nodes because they're cost sensitive. And they'll begin to run the system, and over time they see that their working set size exceeds the size of the flash in the hybrid nodes. And so they'll add an all-flash node. And using our policy, our application intent, we can retroactively go back while the system is running and say, put one copy flash. And using the I/O path, we reprogram the placement maps, the distributed placement maps, to point to that new location. And so this is really an important trade-off that we made early on, which was because we wanted to support true transparent data movement, the complexity of that implementation is significant. But the benefit is you can make arbitrary changes to data placement versus some of the other scale-out systems who do distributed data placement based upon a consistent hash, where the implementation is very simple. But we want to make changes to that placement map, you typically have to take the system offline. Or if you want to associate additional metadata describing what each individual node looks like, that becomes more difficult. And so having a mechanism to change data placement, that is the norm, right, is very important. Yeah.
So on that topic, right, this notion, you introduced two things. You're talking about media placement on the specific individual, drive within the specific individual node. but that's a pain in the neck if you have to manage that manually. So I came from, my company prior to this, talked a lot about policies, and I got these looks on faces from customers I was talking to, like, that sounds like absolute pure hell to me. So talk about policies and how policies and templates work here to make these service classes operate. So VNR, let me start with you on that one, and then let's get into it.
Yeah, I think you touched on something that's very important. And, we talk about architecture where the underlying is composable, right? Charles Milo talked about, the x86 servers, the media, and all of it, right? Now, how do we kind of make this available, the composable and the advantage of that to the applications? That's where the policies and the templates and all of that comes in. Because when we talk to the customers, right, and the customers would say, within my data center, right, I have a tier 0 or a tier 1 applications, and then I have a tier 2, tier 3 applications. And they want to make sure that all of the tier 0, tier 1, even within a single system, are placed on the right media, right? So this is where we could create that SLOs and say that here is my tier 0 that I attach it to a platinum or a gold, and then I classify these pool media nodes that we have, and then as long as this application that's coming from this platinum, the allocations for that, the placements for that happen within that thing. Like Nick talked about, we do the best case provisioning. And as nodes get added, they get classified into these categories that the user has defined, and the policies will actually get allocated to that. So, I mean, it's a really good way for applications to kind of, the administrator to define the policies and attach those policies to the applications, and then it gets placed accordingly based on the media placement.
And so, Bill, how long does it take to create these?
So, I mean,
it sounds great, but right, so that's what I'm getting on the chat line. So might as well just answer it.
Yeah. So this is what we have this concept called templates, and the way the templates work in Datera is you basically are creating a policy set. And policies in our system are the durability. How much durability does the volume have? Policies would be the snapshot schedule. Policies would be the quality of service schedule, the media placement type. And the concept is that once you have those defined, the way customers or users, I should say, consume the actual storage, instead of opening a ticket that says, I need 100 gigs of database storage, and there's a conversation about what that means, the administrators define this template. The consumers, the users of the storage, say, I need storage for my MySQL, this is going to be production, I choose that template, and they don't need to know what is happening on the inside to deliver that. That goes back to what VNR was talking about, SLOs. So the way to think about it is that everything you do as a storage administrator today is setting a specific policy, typically one-off in traditional architectures, to meet a specific request. And the Datera model is to say, wait a minute, let's change this around. Let's create a set of policies, and then as you need to provision storage for your users, you provision it out of those policy sets. And the real magic, as Nick has been talking about, is the fact that that policy is what we call bound. If I make a policy change to quality of service of MySQL prod, and we've got 500 users consuming that particular template, then that policy change at your discretion can impact all 500 of those. So you start thinking about management instead of managing this aggregate or this shelf or these disks or this array. You don't think about that anymore. You think about management in terms of what does the application need to have.
So let me ask the follow-on question then, because this is what I get when I'm talking with folks. Do I change the class of service, the parameters of the class of service, or do I just go from bronze to platinum? And how long does it take? I'm an admin. How long is that going to take me to make that happen?
It depends what you're changing. Some aspects, like the snapshot schedule, the quality of service, those are things that we can do in near real time. Okay. You change the QoS, it gets done. For some of the other aspects, in terms of moving data, retargeting it from one type of media to another type of media, there could be some back-end work involved. That depends specifically on what's happening within the environment. But the concept is you're not bound by an outage. You don't have to even tell the customers these things are changing. You can operate the system independent from what the applications are doing. Incredibly powerful.
So I get on that topic, you know, we've had people call us out online. I'm going to call us all out here. 100% programmable.
Yes.
And we DoTERRA talk about that. And the question that I got from somebody who said he's going to join today's was, you say those words, but what does that even mean and why should I care? So, Nick?
Sure.
You're gig, man.
It means that we're REST first, API REST first. It's not just a veneer over an existing control plane. So literally everything within the system can be programmed through a REST interface. In practice, most people end up using a number of the ecosystem plugins that we support, which is basically every single popular compute environment around. And so this is going back a little bit to the policies and kind of how they relate to being 100% programmable. So, you know, defining your application requirements, that's not new to DoTERRA, right? Chris kind of mentioned that's been around for a long time. But what is new to DoTERRA is the ability to retroactively go back and change those policies non-disruptively while the system is running. And this essentially means that you completely eliminate the need for upfront capacity and performance planning. In traditional systems where you'd have to think ahead, I'm going to need this much flash 3 years into the future, that's hard to do. That's very hard to do. And so when you combine the ability to define your application requirements and define what you want the end goal for them to be, combined with having transparent data migration as a core function of the system, it means that from an operational perspective, we never tell a customer, hey, Mr. Customer, sorry, you should have planned better for what you thought you needed into the future. You can always add hardware, make changes to top-level policy, and get to where you need to go.
So one of the things I love talking to customers about, Nick, is when we're getting into the conversation of what their needs are, and they come back and say, we don't know. Yeah. I love that. Because I think of all the other products on the market, this particular product is the one product where you can basically say, how do you want to start? And then you can start using it, and then you will know what you need to do. And that is a fundamental difference from a traditional sales cycle of, I need to throw a dart 5 years into the future because I get all my budget today, and I have to guess what I need. I'm going to massively over-provision. And if it's underutilized, I just have to eat that. If it's overutilized, I have to eat that too. And this architecture, because it's scale out, it's so simple to operate, it has the analytics, it's got that flexibility. You can literally start with a hybrid system, and every node you add is Intel Optane. That is completely possible.
So the follow-on question just came in, which is basically, does the product do the performance assessment to determine the storage class that's needed, and what changes do you make as a consequence?
Perfect. Can I take that?
Yeah, VNR, go.
Yeah. So this is actually a good question, and you know, we talked about the placements, the data path, and all that. So there are 4 key architectural modules for the DoTERRA product. There's a control plane that's actually the brain. We talked about all the policies that the control plane interprets it, converts that into the key value map that's given to the data plane. And data plane is the IO path. And then the third is the infrastructure. That's what we talked about, where we observe the writes to the NV layer and then flush it to the. The reason why I wanted to kind of give you the high-level view of the architecture modules is the control plane has two main roles. One, taking the user's policies and converting into the map. The other role is constantly looking at system, what is happening. And it gets the telemetry information from the infrastructure. And that's where, you know, all the nodes that are there, how the node performance is, or if there is a, you know, space issues, right? Or if the, you know, the thing that Nick talked about is where we are missing the SLOs. right? All of that will be self-assessed, and we try to meet the intent of the user, the policy that the user has. So the control plane actively is monitoring that. So as you add the new nodes, we will actually assess those and kind of say, here is the, the performance of this node, and this is how it's actually meeting the characteristics of the application.
Okay, so DoTERRA is doing the assessment, and then what does DoTERRA do about it?
That's where, if we need to do change the maps or change the placements, you have a key value map that was given out to the data plane first. And then if we figure out that there needs to be a change, there's a future map that's given so that all the IOs that are happening, all the writes become a union of the current map and the future map, whereas until it's in the write-only mode, once that migration is complete, then everything becomes a current map.
And then take it back to Bill, you talked about not having a plan. So, okay, your overall system needs more resources.
So
what does DoTERRA do about telling you what you need next so that you don't have to overbuy like for all of the vendors that we all came from?
Yeah, so this is one of the aspects of our system that I love is the fact that the policy set that's defined doesn't have anything to do with the physical infrastructure of that cluster. So our customers that have a large number of sites that are running a large number of systems, what they tend to do is to have a consistent policy set, and then they deploy those on all their sites, and they watch their users provision. And as they provision Flash or whatever the policies are, then our insights technology can report on that. The other thing that our technology does is when you're running in real time, we do empirical data monitoring of the data set, and we can determine if the policy is set to allow it, when it makes sense between volumes A, B, and C, which one should be escalated into a Flash response. And that is 100% controlled by customer policy. So you get to choose when you provision, am I going to allow this workload to have that capability? Am I just going to put it in the higher tier? Am I going to put it in the lower tier? And all of those decisions are non-binding. You can change them at any time based on what's actually happening. It's incredibly powerful.
So I got a comment came in, basically someone kind of resonating with that, basically saying, at a previous company, they were asked to purchase all the storage that the company would need for the next 3 years using a best guess for the tier storage mix ratio. And as a former employee of probably one of those companies, I thank you for that, but got a real pain in the neck. We appreciate the pain that you're in. So this is one of the things that frankly killed SDS Gen 1. So Nick, you've been doing this longer than any of us here. Talk about what happened there. Why did it fail?
So the first generation SDS was certainly better than the scale-up architectures that they preceded, but they were still averse to change. Change from the perspective of not needing to know the media that you needed up front, resistant to change, that once you implemented a cluster, you were fixed to that hardware for the lifetime of the cluster. And, many big customers can afford to keep all those extra parts around, but, smaller ones cannot. And so that idea that, built for constant change, where you have a system where you can always retroactively go back and change those policies to meet the end goal for what you want. That's really what was the missing part. Along with, mentioned how placement was actually done. A number of the first generation SDS did use consistent hashing, which made it reasonably inflexible when it came to making changes to the system. So going back to that idea about the transparent data movement, we believe having that as a core function really defines what SDS should have been and what we've done in our implementation, the trade-offs that we've made.
Mm-hmm. So another question that came in is just on, you sounded like marketing there for a little bit, Nick, earlier, where you said we support all the different orchestration frameworks. So Shailesh, will you set us straight? Like, what are we really doing? And what are we supporting? And then talk specifically about containers and Kubernetes, because that's what everyone is talking about today. They may not have started but they're going in that direction.
Right. Thanks, Chris. So this is one of the very important things that comes across a lot of times in any of the seminars or any of the conferences when you attend. People talk about Kubernetes, OpenStack, Mesos, Docker, like what to do, what not to do, how these ecosystems gonna play a role with the solution that I'm building, how should I really go about it, what kind of resources do I need. So when we actually started with the work, as we touched upon, like 100% programmability, the major focus was to provide a very consistent interface that is as transparent as your product does. It's not something that our GUI is not great, but we also provide what our great product can do in a programmable fashion so that people are at their liberty to choose the ecosystem that they want to work with without losing the salient feature of the product. So it became very important over the time, and as the industry is moving towards more and more different consumer-based solutions, different ecosystems coming in, and Kubernetes taking a lead over in the container world, and VMware providing a very sophisticated solution for the VMs. But if I may move towards the container side of it, there are lots of moving pieces, and everybody is asking a lot of questions. Okay, what do I need to do? What applications can run within a container? If my application needs a persistent data requirement, a non-persistent data requirement, how would I pass my application intents down to the ecosystems? That's where our product shines. That's where we built a product which is completely open to take a lot of hints and intent from the applications which are running within the container orchestration. And that's where by converting those hints into ecosystem wide labels and the way ecosystems can consume those changes, we literally have a storage built which basically can take away those hints and perform and provision the things as you want. So if you take a simple example like storage classes, what we talked about, typically the frameworks like Kubernetes, they have a lot of challenges. Why? Because even if you define a storage class and you define a container which is coming out of the storage class, though it says it is bound to the storage class, but once things are provisioned, you make a change to the storage class, the bound entities do not receive a change. The systems are not built for that. So you may get a presumption that, fine, you are linked to something which you will change and it will make a corresponding change into all the bound entities. It doesn't happen. But guess what? When you do with DoTERRA, you are not bound with a change because you bind that storage class to a DoTERRA template, as Bill called out, and you can make the change to the template and it will apply to all the Kubernetes storage that you provision within DoTERRA, and everybody will receive a change. So you are not basically, kind of stuck with that limitation. And similarly, there is all the possible hints related to QoS classes, like what is the performance throttling you want to put in, what are the quota restrictions you want to have in the namespace from a Kubernetes point of view. All those things are directly consumed in DoTERRA environment because we are built tenancy-driven grounds up. And every workload in Kubernetes is a namespace-aware workload as long as they belong to an enterprise class. And during this match, we are a very organic fit to what Kubernetes does. And if I may say, like in some of the respects, we overcome some of the limitations what this orchestration framework has, not because like they cannot do things, because of the pace of development with these frameworks is always limited to what a common consensus can bring. But DoTERRA, we have made our model future-proof. So even if a framework cannot provide you doing certain things, with DoTERRA using a template, we can abstract out a lot of complexity and details, which allow users to use more advanced features in DoTERRA versus what a framework can do.
So, Bill, you're out there talking with these folks every day, but people are getting started with containers. Bare metal's back. We used to call it physical servers. It's back. And we also have lots and lots and lots of VMs everywhere. So what do people want? Are they looking for something to serve one particular need, or do they want to serve all of these at the same time?
I mean, what we see in the field is people looking for agility, that some applications need bare metal. Some applications run fine in virtualization. Some people are choosing to run their containerization infrastructure inside technology like OpenStack because, as Shailesh pointed out, Kubernetes does what it does from a container infrastructure perspective, and OpenStack, for example, and VMware do what they do. There's a lot of uniqueness between those two. So there is a synergy when they start running together. And what makes it interesting in the DoTERRA side, just to build on what Shailesh was saying, something as simple as a snapshot schedule is not a feature that is available in the Kubernetes world. You can't do that. So with the Datera side, we can easily add that from a policy perspective. So no matter whether the user is provisioning for Kubernetes or VMware or OpenStack, that policy becomes consistent and they can have that set snapshot schedule.
So that goes right into the next question that came in, which is, okay, so snapshots and policies, but let's go back to compression and encryption, which tend to chew up resources, you know, on the controller, if you will, in the software layer. So VNR, tell us, how do you choose these, and how do you understand what's being used? How dynamically can you assign these to different volumes and via policies?
Yeah, and I'll also mention some of the things that we, you know, folks normally ask as we talk to the customers, right? One of the things, the moment we say compression, the moment we say encryption or dedupe, one of the things that everyone asks is, how much resources is it going to consume, right? And how am I going to, is that something that can be changed through policy, or can I control it and all? Like we talked about earlier, for us, from a, as we write the data, it's a two-stage process. The first stage is we actually write it to the NV layer, whether it's a NVDIMM or NVRAM, and then once we have a quorum across all the nodes, depending on the replica, we acknowledge to the host, the application. So our latency is what we write to the NV layer. Now, from NV layer, as we destage the data from NV layer to the media, that's when the compression, the encryption, and the dedupe, all that happens, right? So that way the performance impact, and we actually try to make sure that from a resources perspective, we have enough resources that we are actually, monitoring the tasks that we are doing and kind of allocate it such a way that we are not prioritizing the background versus the ingest that is happening from the application.
Got it. And
right?
This is something you control at a policy layer and volume by volume basis?
At the node level and the cluster level, the system level, we can control it, right? Okay. So the compression can be controlled at the system level. The dedupe can be controlled at the system level, and the resources we can actually control it as well. The dedupe is done at a node level. It's a per node, but you can control on or off at the system level.
Okay, so the follow-on question came in is, can dedupe be global? And the answer is sure, but we give you
the granularity at per
make
node.
it extremely granular by policy and at a node level in order to be able to give you that pinpoint control.
That's right.
So on that topic, then, sorry, go ahead.
Oh yeah, no, I was just going to point out with the way that we've implemented dedupe and compression is that we actually take an adaptive approach. So for compression, we will do inline compression until a certain point where we see there's an impact on performance, and then we disable the inline compression and then do it in the background. For the product that we're shipping with dedupe, it currently is entirely inline, and as we continue to optimize the system, we will essentially use the same mechanism where we will disable inline once the system is falling behind, and then do it in the background as well.
And the reason why we do this is because we know we don't have total control over the hardware. And so when you have this adaptive capability, it's not necessarily a question of policy. It's a question of when does it start impacting things, because that's really what you care about.
Yeah. And
as we look at our various types of nodes, when we first started a couple years ago, the capability, I think, was the 2620 V3 was one of our very first nodes, and then we moved to the 2630 line V4. The 2620s can run our current code base. They can bring in these features. It's just they might not be able to do as much compression inline, and they do more post. So by having these capabilities, and it doesn't apply to encryption, but in compression and deduplication, being adaptive means you don't need to set policies. You actually don't have to care, because our system understands the node that it's running on, what its capabilities are, and can make that decision in real time as to whether or not taking that extra step is going to impact performance.
So, Bill, follow on. If what you were trying to say earlier was, you don't have to massively over provision from the get-go. You can just get started and keep expanding. We're going to talk about expansion in a second, but let's hit the question that came in, which is, what if I over provisioned resources for a particular application? Is DoTERRA going to let you, the admin, or even the application owner, know that and make adjustments? How does that happen?
So the system is fundamentally designed with the concept that things are going to change. Whether it's nodes go away, whether nodes are added, that is a fundamental tenet of the design of the system. So as you start thinking about provisioning applications and the real world consumption, all of the previous constraints of RAID rebuild and I put it in this particular shelf or across these shelves, all that's gone. Everything has been provisioned in the system. There's no reason to not do that anymore. The technology and the way we've designed it, there's no overhead, there's no impact. So as the question asks about, if you have a misuse of applications of a particular storage tier, you can add another storage tier at any time. You can remove a previous storage tier at any time. You can adjust the quality of service. You can shape the response to that application in multiple vectors at any time. And all of that is done in a very thin provisioned way. So you can really think about your storage as a global pool of capability. And then from within that pool, you provision to respond to the application. So that is a very classic storage problem that our architecture just leaves in the dust.
And DoTERRA is providing you, the admin, that information. It's providing you those analytics to say, I got too much going on here. I just moved that from one class to another. Is that correct?
Yeah, I can do it through policy and do it real-time local, or we have our portal we call Insights, which can provide, just to dovetail for 2 seconds, the harder part of if there's a hard part, is not that you need to expand, it's what do you buy? Mm-hmm. And that's where the analytics come in really nicely to say, here's your running workload, here are your performance profiles, you really want to add this, whether it be hybrid or flash. The key that unlocks that is something Nick said in the beginning around intent. The fact that we know what you're trying to do because of the policies means the system can intelligently react. That is another one of the core tenets of our technology.
Okay, so let's do the follow-on, which is expansion. Okay, so we said you can grow as you go, but now as a consequence, you've got to expand. So tell me how painful that is, because my old company, that was a...
Yes, so that is a foundational feature of our system, adding and removing technology.
Sure, so how does it work?
So bring up a node, type in the cluster name, and that's it. No manual interaction, no command line operations.
Okay.
Everything based upon the current running policy, both before the node was added and after the node was added.
Okay. And how do I ensure? I mean, in my old world, that meant 2 days worth of rebalancing.
That's right.
How does that happen now?
So that is also controlled by policy, where we can set a gold, silver, bronze level to determine which applications, which volumes get preference in terms of how aggressively we're doing that data migration in the background. By default, we use about 15 to 20% of the overall system performance for the repair and data migration path. That is tunable, of course, but generally that's the amount that we see work best in practice when it comes to being non-disruptive to foreground I/O.
So one of the questions we get a lot from the open source users, won't name the technology, is the pain it takes, and again, Nick mentioned this earlier on, around a difference in fundamental architecture. When you have this concept of a programmatic metadata or consistent hash metadata, when you expand the infrastructure, things have to change. Because we have this intent-based policy, when you plug in the node, we get to decide what do we do. We don't have to immediately move data when the system is changed. You can have a running set of SATA flash nodes, and you can add the Intel NVMe node for future use. Or you could have some previously existing policies that now say, I have that new media type, the policy is to consume it, the system will automatically move it over. So as system administrators, you are in control in making a decision as to how much the DoTERRA system is going to do for you, or how much you want to do with it. It really is the best of both worlds. You can set and literally forget and just ship hardware to the data center, have them plug it in, the very simple node join that Nick described, and everything fixes itself.
So the other aspect of expansion is trial, right? Which is there's a lot of new technologies that come out. People can't go from 100% of one thing to 100% of the other thing. And I know that Charlie sees this a lot with his customers because they get hooked on one drug and then another drug comes along and they at least want to give it a shot. So, Charlie, you had some experience with this in the lab environment you brought up.
Yep.
Talk about being able to try new technologies as they come along so that you can understand whether they're going to work or not for you as a customer.
Yeah, that's a great point, and I think Nick and Bill hit on that, but I just want to go a little deeper on that. In my role, I'm actually talking to large financial customers, and when I talk to them and we have new technologies that could either hit, really good latency numbers with our next media or higher capacities, but they, may be trade-offs in performance. The great thing is, they'll ask, how much does it cost? What's the difference between this price and this price? I think what you heard from Nick and Bill say, with all the metrics and information, the telemetry that's gathered and the hinting through the policy and gathering all this, they can provision those next nodes and know how much is being used. And typically, lines of business, they'll usually pay what it takes to deploy a solution that helps them make their business successful, make them more money. But typically when I talk to IT groups, they're very conscious about how much is it per gigabyte, how much is it per dollar, and so forth. And we get into those, and the minute they hear a dollar amount, they immediately will be sort of conservative of saying, well, I'm not sure we want to pay that much, but they don't know the true value. And in a DoTERRA solution, by putting those products, those types of medias out there and having the choice of different types, they can measure it for themselves. And I think that's the great results. So in our lab, when we did this testing, we put different tiers, SATA, PCIe, NVMe, and even Optane. And based on workloads and benchmarks, we could see, the different levels of performance based on the gathering of telemetry from the DoTERRA solution. But I also thought what was really interesting is that a customer who needed the highest level performance, lowest latency, highest throughput, it may have been the Optane product, but that may have been a little bit more costly than maybe just a standard 3D NAND. And DoTERRA was able to look at that, and have the information to gather, and then they have internal build backs if they wanted to for lines of business. So to justify, if you want to go to the, as you said earlier, bronze, silver, gold, you can look at that and monitor that. So I think that's the real benefit of what you see from DoTERRA.
So you can add these new technologies and just try them out. And by the way, we talked about bronze, silver, gold. If you want to go crazy and you want to have 20 storage classes, that's up to you. You have as many classes as you want.
Yep.
So Bill, you're dealing with customers every day, just like Charlie is. Tell me about expansion and trial here as well.
Yeah, I mean, it's, for the trial piece, there's a bunch of options. We can do hosted proof of concepts. We can work with hardware partners to put gear in people's data centers so they can take a look at it. Charlie mentioned the great point about the different media types. What we often do is we'll actually set up a higher performance node with maybe a hybrid node so that customers can experience what that is, not only to build the system, but to do standard operational aspects. What does it mean to decommission, which is our term for moving the data off so you can get rid of that old system. Failure testing, pull drives, all that sort of stuff. All that common storage stuff.
So I also want to be cognizant of another question that came in, which is really just on the concept of utilization, right? Utilization rates suck in the storage industry. And the question is really about, the idea being, hey, 80% may have been the threshold for actual capacity, or you could start impacting performance. So where can you go with DoTERRA on this magic number of utilization, and what are we doing about it? What metrics are we providing to people so that they can manage it themselves?
Yep. So we start in the 80 to 95%, 90% range. As the system becomes full, that will start to arbitrarily slow down incoming writes to prevent a system from being pushed up to 100% capacity. And that kind of changes based upon media types of the system. But generally, that's kind of the area where we start to have customers begin to add additional nodes to the system. But kind of going back to some of the analytics we can do, a number of things within our system we measure and track. So one good example actually is the drive writes per day in the underlying media. And so, for example, in these hybrid nodes where we have about 6% NVMe flash to a SAS nearline disks, we typically ship 5 drive write per day parts, typically high-end enterprise-grade MLC flash. And so looking at the analytics, we can actually say, hey, Mr. Customer, your workload only uses 2 drive writes per day. And so when they go to add that next new node, we can actually have them use lower cost media because they don't actually need the high 5 drive write per day parts. And so that's a very interesting thing, right? Being able to, one, really understand what the workload's doing and its impact on the underlying media, and then two, being able to tune based on cost and performance, as they add nodes in the field.
Okay. So on that score, in terms of adding nodes, a lot of the folks that are in this market, they may talk about saying they can provide support for just about anybody, but then when it comes down to it, it's really just, hey, you got one option or you got narrow options. So talk about, you've got folks on the line who buy servers from all kinds of different folks. Who can you buy? What can you rely on as part of your infrastructure, and are you limited?
Yeah, so this is Bill Moore, sorry. So we work with a lot of customers who have a pretty diverse population of systems. That it's true to say that there's a big difference between a server and a good storage server. So when you think about how people buy storage and what metrics they're looking at, one of the key metrics is dollar per gig. And when you're trying to optimize for that, you want to put a lot of media in a server. So typically, the systems that we work with, and we support vendors across the board. You can go to our website, DoTERRA.io, to see it. But the major Tier 1 OEMs like Dell and HP and Supermicro, as well as some of the Tier 2 OEMs like Fujitsu and whatnot. So the point is that we work with the customers to understand what are their goals. We map our software to those goals, and then we figure out what the hardware looks like underneath that. So it does matter. We do care. We like having good network interface cards. We like the Mellanox products because they give us a very consistent latency through our tuning on the back end. They also unlock some interesting functionality around RDMA and fabrics. We like to see this NV product, this NVDIMM for certain OEMs or NVRAM cards for others, because you can get those in the commodity channel, and they really provide that enterprise class array experience that we're able to drive from a performance perspective.
So VNR, when Bill goes out and makes commitments, it all falls back and comes to your shoulders. So tell us your version of that story.
Yeah, I think Bill kind of captured, we have the hardware compatibility list that we actually validate, qualify, because like Bill said, from a server and a storage server, there is a difference, and we want to make sure that when we are running a primary workloads, we are actually qualifying it, right? So we qualify it, we kind of put it on HCL, the servers, all of the big server vendors we support, the media as well, right? Charles, we work with Charles. In fact, there are things that are coming out. Charles and I are partnering on supporting upcoming Apache Pass and other things as well. So there are we qualify it in our labs, and so that's part of our building out the HCL as we go.
Okay, so I want to be really cognizant of everyone's time and thank everyone for joining, and thanks a lot for your questions. That was the whole point of today, is to give you what you want to know. Speaking of which, if people are interested, there's a lot more follow-up materials that are out there. You can get our white papers. You can see the HCL list, for instance, who are the server vendors and the media partners. I mean, like Charlie at Intel, that we're working with, so that you can understand what you can incorporate into your infrastructure and get a better sense of what we're up to. We're going to have more of these, so we're going to do another one of these in the January timeframe. So if we didn't get to your question today, we had a lot of questions. If we didn't get your question today, we'll get to it then, or just contact us. We're happy to help you, okay? So with that, I want to say thanks to Charlie from Intel. Thank you very much, and thanks to the DoTERRA team, and thank you most of all to you for making time for this today, and we'll look for you in the future. Until then, we wish you the best. Happy holidays, everybody. Take care.